first step towards any design project is separating it into stages. For our wing design, our team decided to use the stage process of conceptual design, preliminary design, virtual design, detailed design and acceptance, due to the given specifications such as weight and dimensional constraints.
For the conceptual design, our group started off with breaking down the wing into different components and understanding each one by drawing out different shapes for each as a 2D sketch and understanding its viability. We decided to proceed with the load-carrying spar design because of its idealized concept and easy understanding of the forces acting on it.
For a preliminary design, we input values into Excel, changed parameters, and tested the basic spar design in the first lab session. It was evident that increasing the dimensions and thickness of the box beam decreased the deflection, but it also increased the mass of the spar. Therefore, we decided to strike balance halfway between the lightest spar and the strongest one, and agreed on the following spar dimensions.
With an ideal spar design in hand, we decided to test out other spar configurations such as box beam, I-beam, box beam with a vertical support and a box beam with a diagonal support. We only made an Excel for I-beam but realized its unreliability and continued to simulate deflection, torsion and its combination in SolidWorks and found out that the box beam was the ideal spar design with all requirements being met.
Next, we focus on manufacturing technique and build our final spar by folding the foam board with a roller, gluing it together and applying tape to strengthen the spar and improve its deflection and torsion. We then focus on reducing the weight of the spar by stimulating it in SolidWorks and comparing the vertical hose beam, lateral beams, tapered beams, and segmental beams, where the lateral hose beam gives best results.
We also model ribs, leading edge, trailing edge, and control surfaces along the spar, and we choose to connect the control surfaces to the wing using tape and forming a hinge. In our 4 lab sessions, we laser cut the parts from the foam board and constructed the components. But our first ribs design was lacking strength as the laser cut melted all the foam. We corrected the rib design, tested for load requirements, and finished the wing by laminating and ironing it.